So parabola is one type of engineering curve in which the applications are, you must be have seen, you know, our dish antenna, or by which you get internet, or maybe by which you get your television channels. So there is one parabolic plate over here, and then there is a receiver. So all the, whatever waves are there, they come and they hit this particular part, and then they are received by this, and this is now connected to your television or anything like that, right? So that is one application of parabola. Suppose if a sportsman wants to try hitting a ball, so normally the ball will travel in a parabolic path. Even if a defense person, he wants to hit a target with a gun or maybe with a missile, so the missile also travels a parabolic path. Even in nature, if you see, like mostly it is a parabolic path. Okay. So what is a parabola? Parabola is like a part of a conic shape kind of a structure. I think we did ellipse this before this, right? We had done ellipse, and now we are doing parabola. We have done hyperbola also. Have we did hyperbola? No. So what is, now we are doing parabola. So parabola is also part of the conic kind of a structure, wherein we cut the cone and we get different shapes. So when we cut it like this, we get ellipse. When we cut it like this, we get parabola. Now the angle by which we have to cut this. See, this can be, can be cut like this. This can be cut like this. So for this, exactly, the angle has to be equal to this angle. When we see the cone, so there is an angle which we get from the top point of the apex of the cone to the bottom of the circumference point, extreme left. This is called a generator of the cone, and there is an angle which is getting generated. Sorry, this generator is called the, like, whatever you see in the cone, the extreme ends. This two lines, whatever is visible at this stage when the cone is resting like this, so that part is called as generator. So the angle has to be same. While you can see over here, now this is A, this is B. When it becomes B, then it will become a parabola. That is the shape which we will get for parabola. Okay, so that is how we do that. Then there are various ways by which we draw parabola. There are certain methods. I guess mostly you must be having a question on this type of method, which is a focus directrix or eccentricity method or a general method. So by this method, we can draw parabola, hyperbola, ellipse, everything. Okay. To draw normal and tangent. I think we did normal and tangent in ellipse. We did not did that. Okay, fine. Okay. When we do tangent and normal process, that time we will do the process for tangent and normal also. Okay. So there are various types of method of, you know drawing a parabola. First is oblong method. Second is oblong rectangular, oblong parallel. More or the same. These are more or less the same. There's a tangent method. So there is a method in which is called tangent method, and in that mostly students make a mistake while drawing the process, like in the process. Like, so we'll discuss that also. What mistake they do, right? And then we'll see this method which we have already seen last time in the ellipse part. And mostly, very rarely, sometimes students also have this offset method. Now I don't know what type of method you were having, because there was a lot of PDFs. So can you open your PDF and you can just let us see what's there in your sessions? So we'll focus on that only. Okay. Okay. So I can see what you had sent me from I don't know where has got kahan gaya? Pen drive. I think it is there in the pen drive. I don't know. I have taken it. Mm, Okay, let me check if it is there. I've kept your data. Your name. Okay, I don't have your data currently here. Yeah, NIT Surat. Yes. So we are going to do parabola, right? This is what then your notes were. So they are having this method. That is what I guess the eccentricity method, right? And then this is the eccentricity method, and then okay, this is all ellipse and all. Okay, method of construction. They have, see, they have this much. Okay, eccentricity method they have. You have told there is also an offset method. There is also tangent method, and then there is an oblong rectangle and oblong parallel. So basically, you have everything. That's what we can see, right? This is what we have. First, offset. Okay, tangent. Okay, rectangle. Fine. Parallelogram, the same method, and the tangent and normal. How to draw tangent and normal? Okay, tangent and normal again. Maybe some different type of tangent and normal. Okay, no problem. So more or less the same syllabus. Whatever we have doing, we have to do all 5 today. Okay. So let's start. Okay, so draw a parabola by rectangle method. Now they have specified the method. Given base is 150, axis is 90. So let us draw a rectangle first with the given dimensions. Then you divide the rectangle. We'll name them. We'll name them. We will see. So now we are going to divide the whole rectangle into 2 equal parts. Okay. Once we are divided into 2 equal parts, we are going to name the parts like P, Q, R, S, and CD is the middle part. Then we're going to divide this part into 5 equal parts, and then we're going to do the same thing over here. So now we have divided into 5 equal parts. This is a simple process which we know. You are aware how to do this. So 1, 2, 3, 4, 5. Okay. Then I've named them point number 1, 0, 1, 2, 3, 4, and 5. Okay, this is done. Then I take the projections up. I divide this whole thing also now into 5 equal parts, and I make it like this. So I made them 1, 2, 3, 4, 5. Same thing. Okay. Now the next step is very important. Join this point to this point, this point to this point, this point to this point, like this. Yes. Same method as that of ellipse. Somewhat same. But what happens is in the ellipse, we do not extend this lines in the area where we do this kind of constructions. We join it from we extend the lines from one point over here, and then we take the projections. And when we take the projections passing from this, when it goes and intersects on this line, that is the point which we get. One should be coming like this, and one should be coming like this. This is point number 1. It was different. I will show you. I will show you. No, it was different. Yes, I will show you. Uh, Give me 1 second. Ellipse, right? So for ellipse, we had done one small extra addition. Yeah, ellipse. in ellipse, we do this. Yeah, yeah. You can see in ellipse, we had taken these projections over here. We had divided this part into 4 equal parts, but we had not extended this particular things above. We have not taken this line's position up. In parabola, if you observe, what we are doing is, yeah, parabola eccentricity is 1. We will see that. We'll see that method. So you can see over here, there are difference between ellipse and parabola. This part is same. This part is same. Okay. This part is also similar, but it is not same. It is similar. Similar means this thing is done at the box which is below over here. And then we take it only till this part. And then there's a point over here in the corner of the lower box. And from there we extend the lines and pass through this 1, 2, 3, 4 number points in ellipse. And then wherever it intersects, that are the points which we take. Okay, you can see that again. Yeah, over here. You can see this. For us, now currently what we are doing is parabola. So in parabola, we take directly the vertical lines from here. But in ellipse, we don't take it. We only take it till this part. And then from this point, we pass the points, right? So understood the difference? These are they look almost the same, but there is a little bit of difference. And if you don't follow that, you might, make some mistakes here also. So we got points P1, point P2, point P3, and point P4, right? So we got these points. We can get the same points replica somewhere over here. So what I do is I take my roller scale or a drafter, align it parallel to this line, align it here, and then measure it, and then paste, put the points over here. That is how we can do that. So we do that same thing, and we measure it and try to do a mirror of that particular points on this side with the help of a drafter or a roller scale, whatever you feel comfortable. Now we got 4 more points. 1, 2, 3, 4. This was 4, 5. You can name it as P6, P7, P8, P9. Okay. And then we can draw a curve coming from this side. Like this. So this is our parabola. Okay. Now, there is one more method which is similar to this. What happens is, this is called as a oblong rectangular method. In this, the angle is 90 degree because it is a rectangle method. The same steps will be followed for 90 degrees. This angle, right? This one. It's a rectangle. It's a rectangle, right? Oblong means 2 sides are parallel and same length. So oblong means it's also parallelogram is also an oblong geometry. Square is also an oblong geometry. Rectangle also an oblong geometry. But the difference is rectangle is having 90 degree. Parallelogram might be having some different angles, 70, 80, 60, depending upon whatever is given. Right? So now let us see. There is a question which comes similar to this, same steps. Parallel lines, instead of parallel lines, we make it 70 degree to the base. That means we'll do this and we'll follow the same method. Okay, so we're not going to go in detail in that. Drafter is very important. It makes your diagram very easy. It becomes very fast for you to draw it. And if you are not able to use drafter, you better use a roller scale. If you have a roller scale, but I say that prefer drafter wherever it's possible. Yeah. Roller scale gives you error. You have to be like, see, you can draw with roller scale also, but it takes more time because you have to align the roller scale every time, right? That's the reason I prefer to make use of drafter when I'm doing all this kind of any drawing. Okay. This is something very similar, so we not go in details. Already, self-explanatory. Let us go for the next question. Now the question is, draw a parabola by tangent method. So the method mentioned over here is a tangent method. And the base is 150, axis height is 90 mm. So tangent method is the only method in which we take a geometrical, we do a geometrical construction, we do a construction in which the height is 90. Suppose if it is 90, we take height 2 times of 90. If it is 40, we'll take 2 times of 40. And then we proceed with the construction of the parabola. So what we do exactly is, we draw, that's the process, that's the method how we draw. So we take 90, whatever is given to us first, okay, and then we take base 150, right? This is the base 150 which I have taken. Then I take the midpoint of this base. I take vertical lines. This is 90, but I have to take more 90, double the height, and extend this upwards. So this goes somewhere over here. This is O. This is the base. Okay. So this is the first step when you are doing tangent method, that we have to take 2 times the height of the given height of the parabola. So whatever is the parabola height, for constructing that parabola, we take double the height. Then we connect. Better to take what? Half the height means what amount of dimension? This is the base 150. We take the center of this, that is 75. From there we take total 180. 180 because 90 ka double. Which one like this? What? No. So the construction comes, the parabola fits somewhere over here. The parabola does not go up as we do the construction, as we follow the steps, because that's the process called as tangent method. So in that, the points of the parabola will automatically come somewhere over here. It will come somewhere over here. Let us see the method. So we could join both of them, join both ends, and then we divide this line, okay, into 10 equal parts. Now sometimes students divide into 5 equal parts, sometimes they divide into 8 equal parts. I prefer to divide into 10 equal parts. It depends. More number of parts, the more suitable. I know it's very simple, for me to draw the curve. So I divide into 10 equal parts like this. You can see this method I have done. No, not the base. Only the slant height which is there for the triangle. You have to divide only that part. Okay. So I got these points. So I can just name them. I can name it 1, 2, 3, 4, 5, 6, 7, 8, 9. So let us see. So I've done. Now what happens is students make a mistake. So I'm trying to make a wrong diagram now. I'm trying to make a wrong diagram for you so that you don't do that in your exam. I'm going to tell you how students make a mistake. So what they do is, they do like this, and then they join these lines, and they say, okay, I've also divided this part now. So they give the naming 1, 2, 3 till 9, and they also give this naming. So till now it is okay. They feel fine. Okay, I've done it. And then they try to join this line to this line, 1. And then they join from this point to this point, that is point number 2. Then they join this line to this line. Why are they doing this? Because they have done something similar while they were doing oblong method, when they were doing ellipse, and they were doing the same method steps when they were doing parabola. So they think that, okay, if there is something in the end and there are some points over here, I have to connect them like this. But this is not oblong method, right? So this is tangent method. So this kind of construction will not come over here. But if the student is not careful, maybe he must have not studied properly, if he's not focused, he forgets the steps. He might end up doing this. And what happens is, he will get something like this. You can see, he will try to do something like this. So you'll get some kind of structure like this. And then he gets, and then he gets confused. Okay, where are my points? Oh, I don't know where are my points. That means something is wrong. Then he realizes, okay, something is wrong now. So I have to redraw it. Then he remembers, okay, this is not the right step. The right step is something different. Now what happens is, after drawing all this, if he wants to correct it, he has to erase everything. He has spent around 5 minutes to draw this, maybe 10 minutes, depending upon his speed. He has to erase it. That will take 2-3 more minutes. And then he has to redraw again. So again, he will put efforts. So 20 minutes are gone only in making the triangle and locating the points. Right? So be careful that when you're drawing this type of tangent method, this is not the process. This type of construction from the one end to the other points is only applicable for oblong method, oblong ellipse, oblong parabola. Okay. So what is the method exactly? So see, observe here. I've also mentioned over here. This is applicable only for oblong parabola and oblong ellipse. Okay. Now what is the method for this? This is tangent method. So this steps is okay. This is all fine. You have divided into 10 equal parts. You have named them 1, 2, 3, 4, 5, 6, 7, 8, 9, and the O part is the 10th part. And we have taken these lines also, and we have divided 1 dash, 2 dash, 3 dash, 4 dash. Now we have to connect 1 to 1, not from A to 1. We have to connect 1 to 1, 1 to 1 dash. Yes. 2 to 3. Yes. 3 to 3. 4 to 4. 5 to 5. It's like more easy for me to 1 to 9, and then I'm coming from top, say 1 dash 2. Now you can give it 11 also. You can give it 11, 12, 13, or you can give it A, B, C, X, Y, Z, whatever you want. But the process is, whatever is the bottom point over here, connect to the top one. But what I've done is, I've given it 1 and 1 dash. So it becomes very easy for me. I have to connect both of them. To remember, na, it's very easy. So once I have connected all of them, now you can see there is a space over here. In the earlier diagram, when we had joined all of them, there was no space over here. There was all lines, lines, lines. Correct? So now you can see there is a space over here. So you can see there is a boundary which we can see, which is now looking like a parabola. So if you get this, that means you are on the right track. Suppose if you get something over here while doing this method, tangent method, that means you have done something wrong. You have not joined it in the right way. Okay. This is the middle point. So below this, you'll have all the empty spaces. And above this, there will be a mesh of lines which will be coming. So, no, it has got automatically divided. We had divided this point, this line, and then we've taken parallel to this. Then it automatically got divided into 10 equal parts. We have not done it purposefully. It has happened. This is the axis, right? This one. The center wala line. We have no. Yes, yes. So if you have, if you draw two parallel lines, we can get the same answer. Yeah. But what happens is, teacher expects that you do this. You show this part. If you do this, then he might say, okay, she has not done something right, and he must have done some shortcut or something. But the answer comes same, right? But he expects that you draw this construction and show it. So that's the reason we do it. Okay. We can do it either way. You can directly divide this line also into 10 equal parts. Whatever is the slant height, you can measure it. You can calculate the divide by 10 and you can find the answer. You can directly take the points from here then. Suppose if this is 200, so you can take 20, 20, 20 on the slant height. You get the same answer. But I have done this because this is what they expect you do by this method. Okay, so once you have done, yes, depends upon teacher to teacher. What does the teacher want? The teacher wants only the answer, then he's happy with anything. The teacher expects that you also draw this, then he might say, okay, you have not shown, so I will cut your marks. Right? Chalo. Now you can see there is a set of lines which are generated over here. So if I start from this point, I have to go on making a tangent, freehand tangent over here, touching all these lines and coming like this. Yeah, so you can see I have done it like this. So there are no points coming over here. Remember, in we can do that. We can use a French curve and we can make it. Yes, I can. I no. I will teach you a trick how to do it. Okay, I will teach you a trick. It's very simple. It's very fast actually. You know, and once you know the trick, you will be able to. You'll be like always using French curve because it will become very fast for you to draw the curves. Okay. So we have done this. This is the answer for this. How to draw a tangent how to draw a parabola by tangent method. So you can see the base is 150. So this is the 150 base, and the height which I have received is 90. So this was the part of the construction to achieve this. Okay, that's how we draw it. Parabola is done. Okay, by tangent method. Now let us draw parabola by general method. We have seen general method in ellipse. We have seen eccentricity. When it is less than 1, it is ellipse. Which is equal to 1, it is parabola. And when the eccentricity is more than 1, it is hyperbola. So now they are specifically saying, draw a parabola when the distance between focus and directrix is 70 mm. Also draw a tangent and a normal at a point 50 from the directrix. Let us see. So we know that for parabola, the answer of eccentricity should be 1. Right? That means distance from the directrix and the focus. Distance from the directrix and the focus is given, suppose x. So the vertex which is there V will come in the midpoint of both of them because the eccentricity is 1. So that is the hint. Sometimes they will not mention this. Parabola is, draw a parabola. Like that they will not mention. They will tell you that draw a suitable curve when the distance between the focus and directrix is 70 mm and the distance between the directrix and the vertex is 35. So what happens is in that case, you are aware that the directrix and the vertex always comes in between the focus and directrix. So if it is given 35, that means the other half is also going to be 70 minus 35, which will be 35. So if I divide both of them, it will be 1. That means the curve which I am expected to draw over here is going to be a parabola. So they will not clearly mention that you draw a parabola. They will say, draw a suitable curve. Or sometimes they will say eccentricity is 1. Yeah. Eccentricity is the ratio of the distance between vertex to focus upon vertex to directrix. We have seen that. Let us see again, once again. I hope. Yes. This one, right? This is the focal point. This is the directrix point. And then there is a point of vertex over here. So that is the ratio which you take. The distance of the point from the focus upon the distance of the point from the directrix. So there is a point over here somewhere in between both of them. That point is the vertex point. From where the ellipse starts or any curve starts, it is a vertex point. Okay? Chalo. Let us move forward. So we know that eccentricity is 1, curve is a parabola, right? And we also know this formula. So let us now go ahead. We'll first make a rough line, a random line, make it vertical, and then draw a horizontal line. Now the dimensions are not necessary. This can be any vertical line, suitable line. Okay. Then we are aware now that the directrix and the focus distance given is 70. So I know that this is my directrix. From here I can take a focus ka distance point. I can mark a focus on this. So I can just name them A dash, B dash, and the middle point I've named is C. Okay. Now I know that it is 70. So I made a 70 mm ka horizontal line parallel to this, and I've taken a line down with the help of a drafter, taken it down, and I've marked a point F. This is the first step. Now there is going to be a vertex somewhere over here in between both of them. This is focus, this is directrix. So that is going to be in the midpoint now, because the parabola eccentricity is 1. So I'm going to mark V somewhere over here at a distance of 35. I'm going to mark a point, and I'm going to get a point is this. V is equal to, is in the midpoint, right? So 1 is VF and upon VC. This is the answer. Okay. Now follow the same step what we had done for the ellipse part. We are going to follow the same steps for parabola also and for the hyperbola also. Take a random line at any distance. Give it line number 1. Take the point C1. So where is C? Is over here. 1 is over here. This distance. Take it C1. Keep it on vertex or keep it on focus. Keep it on focus. Make a curve. It will cut over here and over here. So this is going to be point number 1, point number P1, P1 dash. So I have written over here this thing. C1 distance, C to 1 distance is equal to. So the parabola is going to come like this now. The parabola earlier was coming like this. Now the parabola is going to come like this. Half down, half up. Okay. So this is first step. I can take one more random line, point number 2. Take the same distance, C to 2. Keep it on F. Make a curve. Make a curve. I got one more line. Take a random line 3. Anywhere. Distances, I can take suitable distance. Now what happens is, when I'm going to take these points, we have to always make sure I am going to measure C to 3. Right? Always. C to 1. I was making it with the help of compass, right? So compass is now able to open and measure this length. Then C to 2 also is open to and measure its length, right? Then sometimes if you take it very far, maybe sometimes somewhere student will take somewhere over here. The compass does not get open depending upon the compass. Some compasses they do open, some compasses they do not get open that far. So you don't take it too far. Your limit for taking the point is the ability of the compass, how much it will stretch. Okay. So depending upon that, you calculate how much work. Couple last cuts would be further away. Sorry? No. See, when you are practicing, you will get an idea how far I can go with the help of the compass. So if you have an old compass which is not stretching out, so you can keep two type of compasses. One for specifically drawing a parabola, hyperbola with this method. You can use a compass which can, stretch far away. Normally, I suggest to use a compass which is, the pen pencil, that point is there, the lead pencil. With that, there is a compass of brand called Maped. That compass is quite good. It stretches very far. And it also has a facility to put the leads. With that, I guess it will stretch open quite good, quite well. And it's good quality also. Okay. So avoid drawing. Show me. You can show me in the video. You have it. You can show me. No, this one is not the one. No. Yeah. Huh. Right. Right. You can try. Yes, you will get the correct answer. You can get the correct answer because the distance is there, na? You're getting the distance. You can pencil, correct. You are yes. You can do that. That can also be done. That's a good trick actually. Okay, so let's go for the third point. Same C to 3 distance. Want to keep it on F. Mark upper, mark niche. 2 points. Okay. Now Again, fourth point, any random line, C to 4. Keep it on F, mark a line, mark a line. Okay? Then take a 5. If you want, you can take one more 5. Depends upon your compass. If you want to take 5 points, you can take 5, you can take 4. I've done the same. Now I'm going to join the vertex point. From here is the origin of my curve upwards, and from here is the origin of my curve downwards. So I'm marking a vertex wala line, vertical line. Sorry. At what distance? Which curve? This one. You can, it depends. Like you want 4 points, so you can stop at 4 levels, 4 lines. I prefer to do at least minimum 5 lines because it will give you a smooth curve. If you only take 3, you might not get that kind of a smooth curve. You might just struggle to make curves after this. But if I take 5 points, I can take a curve like this. Okay. So I'm making a curve like this and down. So you can do it with free hand if you're very good with free hand, or you can do it with the French curve. So I will teach you how to draw that with the French curve. Maybe we'll have a session for drawing with the French curve. Okay. Okay. So done. We are done with this. Now it is asking us to draw a normal and a tangent at a point 50 mm from the directrix. This is the directrix. Okay. And now I take a line 50 mm away from it, a point, and I draw a vertical line. This vertical line will intersect somewhere over here. You can see this line. I have made it. This line is coming and intersecting somewhere over here. Now this is the point from where I have to draw the normal and tangent. So what I do is I connect this point to the focus point, and from that I take a 90-degree line and connect it to this point. So what I did was I got this point first, point P, connected to the focus. From the focus line, I took a 90-degree line. It went till here. I got this intersection point. From this is now going to be my T, and from here I can draw a line connecting this point. That will be my tangent. You can see this, what I've done. You can do from here also. Either way. You can take it from up also, you can take it from down also. But the so suppose if you take distance from C, it is 50. So 50, the total distance is 70. So this distance will come somewhere over here. Right, this length. Suppose if you take from focus, it will go somewhere over here. So this distance itself is 35. You will not get a point on the curve. Your point will go somewhere over here. You have to take it from that position itself. Okay. That is how we draw the normal and the tangent. So now once you have drawn the tangent, take this point and draw a perpendicular to that point with the help of a drafter. You can set it and you can draw it, and we get the normal n and n dash. Okay. So this is how we draw the normal and tangent to this point. Now next method is construct a parabola of base span 80 mm and rise 50 mm by offset method. Now this is the last method which we are going to see. Right. So what is offset method? We have got the base and rise 50 and 80. Now there are some calculations in this. Very simple calculation. Before that, we'll do some constructions. We have named the box A, B, C, D. Okay. So ABCD is done. Divide it into 2 equal parts. Name it as OE. Okay, done. Then divide this part into 3 equal parts or 4 equal parts. 1, 2, 3, 4. Now, this is going to be, sorry, any number of parts. You can divide into 5 also. Yes, we can divide it into 4. You can divide it into 5. The moment you divide it into 5 equal parts, you have to do 5 calculations. If you divide it into 4 equal parts, you have to do 4 calculations. If you divide it into 3 equal parts, you have to do less calculation. But what happens is the curve's point which you will get is very less. And to draw a curve, with that less number of points, will be a little difficult for us. That is the reason I prefer 4-5 points, max to max, not more than 5 in any construction. So here now I've taken 4. I've taken 4 over here. Okay. Now observe carefully. This part is 1/4 of this whole line. This length is 2/4, means half of this length. This whole line is 3/4 of all this total length, right? These are the calculation which we are going to use. 1/4, 1/2, 3/4. Okay. And we're going to plot some points over here on this line. And then we are going to connect these lines and we're going to get a parabola. So what are the calculations? This is point number 1 division, point second division, second, third division. I can do the same thing over here. I have to give it in a same manner. 1, but in a reverse way, right? 1, 2, 3. Okay. Now the calculation is E1. Suppose I have to draw, suppose if I want to take, see this distance to this distance. What is the distance from here to here? E1 is 3/4 of ED, right? This point to this point is 3/4 of total length. This is 4 lengths, 4 parts. This is 3 parts. So this is going to be 3/4. And if I do these calculations for offset, 3/4 the whole square into EO. What is total EO? EO means total height. So now every point, every division, I have to take a point on that division. There's going to be some point over here. There's going to be some point over here and some point over here. And then we connect them and we get the parabola. AD and no, we are not dividing this AD into equal number of parts. AD we are not dividing at all. We are trying to plot a point. This is going to be, suppose this point, one point is over here. Okay, one point is over. This is going to be the 3/4 part of the whole line over here, ED. So we do the calculations. Yes. Then this is the calculation, 3/4 square into EO. And with total length, whatever is the length, P1 we have to mark now. I'm going to mark. That is at the height of 20. Yes. No. See, if you divide this into equal number of parts, what will happen? Let us first see this method. What is happening? P1. So point P1 is at a distance of 28.125. So I'm marking 28.125 from here, and I'm marking it a point over. So I'm taking from top side. Okay. I'm marking the same point over here from this distance. Calculations for this line, level 1, this partition 1 is done. Now I'm going to take the partition 2. What is point 2? This point is half. Okay, half of this whole total length, right? So E2 is going to be half of this total, right? This is how much? So E2 is half of ED. So calculation is offset for 2P2 point. So from here, I'm going to take a point P2. The square, this is square. There's a formula for the offset. So this is half of square into total length of the ellipse, the parabola. That is EO. We are going to get the answer 12.50. To take this point from this point, mark 12.5. You got this answer. This is the point. So you do the same thing over here. Got one more point. Follow the same thing for the point line number 3. So what is this? This is going to be 1/4 of the whole total length from ED. Is 1/4 part. Do the same calculations. 1/4 square into EO. That is going to come somewhere 3.12. Mark it, this point over here. Now you were saying then the last point is up, right? Then you connect these lines. That is the parabola. Now you are asking what will happen if I divide it into 4 equal parts and then draw the curve. That was your question, right? So let us see what happens. Suppose if I take it into 12 equal number of parts. So this is like total height is 50, rise is 50, right? So 4 equal parts means it will be how much? 4 divided by 50. That will be approximately 12.5, right? 12.5. So this first point will come at a height of 12.5. Other will be in the center 25. Then the other one will be somewhere over here, and then the other one will be here. So if I take a point like this, suppose the center will come somewhere over here, midpoint will come somewhere over here, and this part will come somewhere over here, right? This point, right? Then suppose if I connect this point to this point, so you can see this point is coming and making over here. It's not matching, right? So this part, if you draw like this, you will get a curve like this. This is not the, it's not a parabola. This looks something different. Something different, some different curve, but not parabola. Maybe kind of a triangle. Yeah, you get a triangle, I've made it smooth. If you connect it, you will get a triangle shape. It will not be a curve, it will be a straight line. Okay. So yeah, basically, so these are the five, I think five types of methods for drawing parabola. That's what, this is the application in nature. If you see any flow of water, when you just hold it in the air, it forms a parabolic path. This is one of the applications. So we are done with parabola now. What do you want to study next? Tangent for ellipse. Let's see if I have tangent. I think we have done tangent for this. We drew tangent for ellipse for focus directrix method. So we had not done this, right? I think we were studying this and then we just left over here. We were discussing this, right? And I was trying to tell you that the question, if it comes something related to distance of focus and directrix, it does not necessarily mean that it is eccentricity method. The question can be of a simple arc of circle method. That is what we were discussing, right, last time. And then you got confused, sir, why are you telling this and why are you not telling that? So I was trying to explain you. Now, sometimes teachers, they put distance between focus and directrix. Okay, and they will not give you eccentricity. They will not give you any eccentricity value. They will not give you vertex value. They will not give you any value. And then students get confused. What is happening? Why I'm not able to get the answer for this type of method? But for this type of method, you always need a value for E, eccentricity. So teachers, what they do is, they know students have studied this, by-hearted this. Wherever they will see focus and directrix method, distance is given, their brain will start thinking in these terms. But the actual reality is, they have given you a hint for this. And they have given you a minor axis ka length. They have not given you major axis ka length. And then you can calculate that and you can mark the major axis and then you can solve the same problem by using simple arc of a circle method. That was the discussion which we were doing last time. So now we'll try to go for this one. How to draw ellipse and by using focus directrix method and how to draw the tangent for the same. Okay. So draw the curve if the distance of focus from directrix is 70 mm and eccentricity is 3/4. So now they simply said, okay, eccentricity is given. That means it is less than 1. It is going to be a ellipse. Now they have not mentioned draw an ellipse. They have said draw a curve. We'll draw tangent now after this. Once we'll draw this, we'll draw tangent also. Now we'll go You have not done anything? Sorry? You have dinner. Okay. So it's about 7:45. So you want to skip this and come the next session? You want to continue in the next session now? Okay. So now we'll just follow this. No, we have not done this, but we'll just finish this fatafat. I'll just fast forward it. So the eccentricity is given 3 by 4. 70 is the distance. So I know that my point V is going to be somewhere over here. And the eccentricity is 3 by 4. So this is going to be 3 part. This is going to be the 4th part. Right? Right. So V is going to be somewhere VF and 30 and VC is going to be 40. So I'm going to mark point V over here. So VF is going to be 3rd part of the 70 and VC is going to be the 4th part of the 70. So I'm going to mark VF and right. So VF is 30, VC is going to be like that, 30 and 40. Then I do the same thing. I take a projection upwards. Now for ellipse, I do projection is upward. I take VF is equal to VB. So this length I will take and I will take VB. I will draw a line from here. So now see the construction is a little different. I'm going to draw a line from here. And then I'm going to talk a 45-degree line also I'm from here. From this point, I'm going to take a 45-degree line. And then you start with the same process. Take any random, I'm going to mark the center of this, V dash and V. Sorry? That's the method for this making ellipse. Okay. Now divide the lines into some random points. Okay. Do the same method. 1, 1. I'm going to take 1, 1 is equal to FP1. So 1 to 1 distance. Earlier we had taken what distance? This distance. C to 1. I kept it over here and made a cut for parabola. Okay. For now, for ellipse, I'm going to take this 1 to 1 distance, keep over here, and then make a curve cut. Cutting. Yes. So we go for point number 2. Same thing. 2 to 2. Yes. Yes. So I'm just writing down everything over here. So be careful. In parabola, we do C to 1, C to 2, C to 3. But in ellipse, we take 1 to 1, 2 to 2, 3 to 3, 4 to 4. Okay? I've written down over here. And then you draw the curves, cut it, and then this is the type of points you will get. And then you connect on all of them. I have see this is a center point for me. So ellipse will come from here, reach the maximum height at the center, and then come down. So I'm also marking the center line. This is going to be V1, V2. And I'm going to make an ellipse. Now tangent. Same, also draw a tangent and normal at the ellipse at a point of 80 mm from the directrix. Take the point from directrix at a distance of 80 mm. I marked it over, I'm put it over here. I can make it here or I can make it here. Either way. I'm taking it over here now. Take a point P, connect it to the focus. First step is always connect it to the focus. From there, make a perpendicular 90-degree line, get it over here, then connect it to the back. Yeah, connect to P. That is a tangent. Then make a normal over here. That is the normal. From where, which point? F. Uh, uh, we get this point, the end of the ellipse. We're getting the end of the ellipse. Because ellipse will come a full circle, like it will come like a closed curve. Sorry? No, this is not focus. This is the end of the curve. So when we started, we had only one focus point. Distance between this and this was given. We were not given the center of the curve, center of the ellipse. We are not given the end of the ellipse. So to find the end of the ellipse, we did this construction, this part. So now see, there is nothing. We only have this part. We have got this. I took it upper, right? I got this length. Then I made a connection like this. And then from here, I took a 45. I got this point. And from here, I took a line down. That is going to be the end of my ellipse. My ellipse is going to stop over here. Now the center is going to come somewhere over here. This is going to be O between this part and this part, right? V and V, vertex. Okay? There is no focus over here. We have only got one focus. If you want, you can put one more focus here also. Make a focus here also. Then, but there is no need for doing that. So we draw this part and we continue with our construction of ellipse. Okay? So I hope this is okay for you now. I think you have to leave for the dinner. So you can go. You can meet again next time. Acha. How is the dinner at your hostel? It's good? Okay. Acha. How many mess do you have? Like you can go to only one mess, or you can also switch to other mess. There's one canteen you have for your one hostel. So you don't have multiple hostels, multiple messes. Yeah, boys will be different, but the mess is same for all of you. It's like a canteen. Okay. 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 So the menu will be also different to that place. Acha. And okay. And you cannot go to their place and eat in case if you want. You cannot go there. You're not allowed to go there. Okay. What about boys cannot come to your place? Okay. 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 Good. Better than I guess I hope better than VJT hostel when I was studying at that place. The mess was also very messy. The mess was messy. Anyways, chalo. We'll end the session over here. You can go and have your dinner. Okay. Yeah. Yeah. Bye.